All right, now what happens, like I said, if you cannot solve the equation for y? Until now, we were able to solve for y. So let's take a look at 2 to the power x. So I'm going to write y equals 2 to the x equals 2 to the y. And I want to solve for y. That doesn't look like anything I can solve for. So sometimes when you cannot solve for y like that, because the y is in the exponent, mathematicians create a new notation. So let's see what we get. We know that x equals 2 to the y, and we cannot solve for y, so we mathematicians sometimes have to invent new notations to describe this process. So we say y equals log base 2 of x. So these are logarithmic functions. Logarithmic functions are inverse functions of exponential functions. So log base 2 is the inverse function of 2 to the power x. How do you read this? Log base 2 of x. So the name of the inverse function of 2 to a power is logarithm base 2, denoted as log subscript 2. Okay, what does that mean then? We know that the domain is negative infinity to infinity because I can put any number I want here. So that should be also the range of f inverse of x. But now what about these values? I know that 2 to the x can never be 0. So the range of this function is 0 to infinity. We saw that before. So that would also be the domain of this new function, log base 2. All right, well, let's take a look at a graph so it will give you more insight. So here's the graph of 2 to the x that we drew before. So now what do I want to do? I want to plot points. In order to look at inverse function, all of these coordinates here will have to be what? Reflected. Good. All right, let's plot points. We know to plot inverse function, we would have to take these points and make x coordinate y and y x. So 0, 1 will become 1, 0. The point 1, 2 will become 2, 1. The point 2, 4 will become 4, 2. The point negative 1 and 1/2 will become 1/2 negative 1. And the point negative 2 and 1/4 will become 1/4 negative 2. So we know our graph is going to go this way. So here is our graph. The same graph reflected about y equals x. So this would be the graph of log base 2. All right, let's take a look at what happens when you have a smaller than 1. So 1/2 to power x was this. So logarithm base 1/2, what do you think we should do? So you can see that the point 0, 1 will become 1, 0. The point negative 1 and 2 will become 2 and negative 1. And so you can see it will be a graph going this way. So that's the graph of y equals 2 to the x. That's the graph of log base 2. We just saw that. So in order to evaluate, then this is what it means. Log 8 base 2 means 8 is 2 to the third. So log 8 base 2, you're asking 2 to what power gives me 8? That would be 3. So log 8 base 2 is 3. And we'll do more examples like that in a little bit. So what is a logarithm? Inverse function of exponential functions. That's what you need to drill it in your head. Log base 2 of x means inverse function of 2 to the power x. So in general then, f of x equals log x base a, where a is not equal to 1 and is a positive real number, because that was the restriction on the base when we looked at exponential functions. What does that mean? This is the inverse function of a to the power x. So if I wanted to compute log x base a, you're looking for a to what power gives you x. That's what it really means. So look at the graphs. X equals 0 is our vertical asymptote because before we had y equals 0. as horizontal asymptote. So the asymptote became x equals 0, and that was the generic shape. If you have a number smaller than 1, then you end up with that graph, because remember, this was our, over here, this was our graph of a to power x, and this was our graph for a to power x when a was smaller than 1. And so reflecting across the x, y equals x line will give you this graph. All right. So domain is 0 to infinity. Range is all real numbers for both those functions. And yes, it is 1-to-1, because otherwise we couldn't have taken the inverse function in the first place. All right, so evaluating log x space A means what? A to what power gives you that x? So for example, if I want log x base 3, 3 to what power gives me x? So how about you do that? Go ahead and find log of 1/9 base 3 and log of 3 base 3. 3 to what power gives me 1/9? 3 to what power gives me 1/9? We know 1/9 is 3 to the -2nd power. What about 3? 3 to what power is 3? Good. 1. All right. Evaluating log x space A means asking A to what power is x. I'm doing it over and over and over again, even if it's annoying to some of you, because this is a very important concept which sometimes students have trouble understanding. So that's why I'm repeating that evaluating log x space A simply means finding A to what power is x. So we have base is 10, 10 to power x, then the inverse function will be log x base 10. When it's base 10, because it's used so often, we just don't write the base 10. So no base written here means it's base 10. Just make that note in your head. Logarithmic scales, graphs are used in geography, physics, chemistry, lots of different places, finding pH of solutions in chemistry. So there are many applications of exponential and logarithmic functions outside of mathematics. So plot the function, its inverse, and evaluate. So I'll let you do the plotting, but let's look at log of 1,000. What does that mean? 10 to what power is giving me 1,000? So 10 to what power is 1,000? That would be 3. All right. How about log 0.01 and log of 1? Well, 1.01 is 1/100, which is 10 to the -2nd power. 10 to the 0 power gives me 1. Pay very careful attention to how this was done. There is another number that should be of great interest to us. When we were doing compound interest, you saw this. If you take compound interest and compound it per minute, per second, what happened? When we went from day to hour to minute to second, we saw nothing really changed much. You still got pretty close to a particular number in terms of your interest. And so in general then, if you look at numbers 1 plus 1/n to power n, and you look at n goes to infinity, like 100, 10, 100, 1,000, and so on, what happens is that you really just get a number 2.718. All right, so let's take a look at 1 plus 1/n to the power n. So when n is equal to 1, we end up with 2. What about n equals 10? Well, then we have 2.59374, and you can have more digits. We're only looking at the few digits here. What about 100? What about 1,000? Look at what is happening to that number. What about 10,000? So you can see it's already 2.7 something. It's not going to get any bigger than 2.7. We have 718 right now. Let's add another 0 and see what happens. You can see only these digits change, so it's 2.71. Let's add one more 0 and see what happens. So you can see how 2.718, so it's approaching a particular number. This is an irrational number, so the number of digits just keep on going, and I'm only looking at a few digits right now. So E is a number. What kind of number? An irrational number, 2.718 dot dot dot. All right, so let's look at f of x equals e to the power x. So what is e? Is e a variable? No, it's a number, 2.718 dot 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 approximately. Anyway, so f inverse of x is going to be log base e of x. And log base e has another notation, which is natural log. And the reason is because e to the power x is a function that occurs in nature in terms of when you're describing population growths, bacteria growths, exponential decay for radioactive substances. So it has a special notation, ln. So you have ln, or natural log, that's how you refer to that. Natural log of x is the inverse function of e to the x. So if you compute natural log e to the x, you'll end up with what? So natural log e to the 2 would be 2, because e to what power gives you e to the second? That's what you're really asking. So you're saying e to the what power gives you e to the 2, so the power would have to be 2. So remember, natural log e squared means log base e of e to the second power. All right, what about natural log 1 over e to the third? That's the same as saying e to the negative third or negative 3. And natural log 1 is going to be 0. Look very carefully what is happening. Here, when the base is e, natural log of e, the second power is 2. Here, 10 to the third, base is 10, we got 3. And so we will study logarithms in more details and properties of logarithms a little bit later, but not here.